Stats 5.5, our fourth installment here of getting the permutations and combination stuff taken care of. All right, just a couple examples here that I think we should go over and help you set some problems up. That'll be beneficial to you. So, let's do a few. All right, example. So there's all sorts of lottery games out there. In Ohio's Classic Lotto, in order to win, you got to match 6 out of 49 numbers. So they got the ping pong balls, and they put them in the tumbler, and they have them shoot up there. And the numbers are from 1 to 49. Question is, what's the probability that you get a winning ticket? That. Sorry. Okay, so first and foremost, it's probability. Something out of something. All right, so what we want out of total possibilities. What we want. So, what are we going to do? Find total possibilities. And then, that means we want the total possible outcomes. So let's look at a couple different ways here. One way would be we gotta get 6 of them. So 1, 2, 3, 4, 5, 6. So one of our options is to do this. So we gotta get 6 of these balls out of 49. So in the first one, you have a 6 out of 49 chance. All right. Once one of our winning balls is chosen, then we have a 5 out of 48 chance because they don't get replaced. We then have a 4 out of 47 chance to get the next one. Next one, 3 out of 46 chance. Next one down, 2 out of 45 chance. And finally, the next one down, a 1 out of 44 chance. Which, as we do this, if you did all the multiplication through, you get 720 as a numerator, 6 times 5 times 4 times 3, or 6 factorial, think of it that way, over well, let's see here. Thousands, yeah, 10,068. I'm sorry, 10,068,347,520 possible outcomes, possibilities. All right, we get 720 of them, which as everybody knows, we're reduced down to so you got a 1 in 13,983,816 chance of winning that, picking the numbers at random. Now, you can do it that way. Or let's look at what we're dealing with. All right, let's look at what we're dealing with. Do we care about the order? No, doesn't matter how they come out of here. So we need 1 out of 49 possible, and we need 6 of them. So as we bring out our handy dandy calculator and let technology help us out, we're going to do 49 possible. Order doesn't matter, so we go to here, combination, and we need 6 out of those. And we see that number, oops, sorry, maybe you didn't see that. We see that thing showing up for us. So I'm saying figure out if it's a permutation or combination. Get the calculator out. You're getting the same answer. 13,983,816. In other words, a small percentage, a small shot at winning, but use the calculator to figure it out. Now, let's change the question. What if as a challenge the high lottery does this? What if you had to match them as the numbers are drawn? So in other words, the order they come out. Now what's going on? Order matters. Order matters. So again, you got your 2 choices, but now I don't have the possibility of any 6 happening. I got to have only 1 happening out of that 49. Then only 1 out of the 48. I got to match only. I can only match 1 out of the 47, and so on to that. Which, well, we already know the answer. We did it up here. $10,068,347,520. You can see if the order matters, your probability of getting that greatly diminishes. Your chances are less, if you will. But since, again, order matters, let's use technology. So the order matters is not a combination now. We need 1 in a permutation. And again, let's use our calculator. Yeah, there we can see the answer right there. I'm just going to do that. So now I got 49 choices. Permutation, because order matters. And we want 6 of those numbers coming out of it. And again, they give it to us in scientific notation. We'll write it out like this. Got the same thing going on. Same thing going on. So then the question is, do I write it in scientific notation? Or what do I do? I'd say a rule of thumb. If it's up in the 20s and huge, then go scientific notation like this. We can write this out. So take that in mind as you're doing it. So let's check this example out. Bear with me, got to write it out a little bit. But let's. Amy Jean, Keith, Tom, Susan, and Dave have been invited to a birthday party. Okay, they arrive randomly. Oops. At different times, each one. So nobody's riding together, all individual. How many ways can they arrive? First off, there's the first question. In how many ways can Gene arrive first and Keith last? And finally, find the probability that Gene will arrive first and Keith last. Okay, so let's break it down piece by piece, part by part. Okay, so let's deal with step number one. It says, or question number one, I guess. In how many ways can they arrive? All right, well, how many people do we got? 1, 2, 3, 4, 5, 6. Okay, so since we have 6 people arriving, we're going to have some kind of, any 6 of them could arrive now. But then once that one's gone, so then there can only be 5 that can arrive in this place. 4, 3, 2, and then 1. So 6 factorial, or 720 possibilities that they could arrive. Now, think about it. This is where some arguments come up into play. Does the order matter? Well, yeah. If Amy arrives first, then somebody else, then somebody else. So it's got to be, they can't, whoever arrives here can't arrive here. So the order is going to matter in this. Which means we will use permutation or combination. For those of you that said permutation, you are correct. Well, we have 6 people, and we want the order of 6 of them. So as we use our calculator, 6, PRB, permutation, not the combination, and 6 people, 720. So 720 ways all these people can arrive. So there's the first question. Second question, then put some limitation on it. We want in the second question, Jean has to arrive first. There's only one way that can happen. She's only one person. And 2, 3, 4, 5, 6. Keith has to happen last. Only way that can happen. There's only one Keith in our group. So now that changes things a little bit. Jean only, Keith only. How many possibilities do we have here? Well, there's 4 people left. How many possibilities now? 3, 2, and then there's only one person that can finish that. So, as we do that, you multiply them together, you get an answer of, there's 24 ways with Jean first and Keith last that this can happen. All right. Does that order matter again? Yes. So it's a permutation, but these 2 are locked in, so they're not part of what we're worried about. So we only have 4 to choose from, so that's very crucial, and you got to be very careful with how you're setting that up. And then as you plug that in, you'll get 24 as well. So now our probability. As we know, probability is what we want over a total. So what we want over a total. So let's look in. So we're looking here. What do we want? Question number 3. Probability Jean first, Keith last. So there's what we want. There's 24 ways Jean can happen first, Keith can happen last. Out of how many possible ways can all these people arrive? So as we divide that out, we're going to see that answer. So we can also use our technology if we want to. This is a fine way of doing it. But let's use what we got here. So what do we have? Desired. We want those 24 ways, so what did we do? We did 4. I mean, if you want to get technical, times 1 times 1. That's that middle ground that we were figuring out here. Most of you probably won't put that on there. Over, how do we figure out our total possibilities? There are 6 people in order. And as we do our calculator, we can set this up. So we'll go through the key sequence for you. So our numerator, we needed 4 permutation, 4 equals, divided by, I'm going to put parentheses in it just to make sure, 6 permutation again, 6, close my parentheses, and there's our repeating decimal that we got. I'll do one more example for now, and then I still have one more to go, so I'll load that up a little bit later today, though. So Taking me a long time to write these things out. Okay, so looking at this example, here's our problem. Got a shipment of 120 copies of the movie 21. Four copies have disk error. And you just can't read it. It pauses, it skips uncontrollably, whatever. Let's say it skips. So here's a couple different questions we have here, about two of them. First one, find the probability of selecting one out of four UT that skip. Okay. So we want 1 out of 4. How does this differ from the other examples? No. The answer to the question is we want 1 out of them. We don't want them all. So let's look at a couple different things we can do this. So we want 1 out of the 4. So it doesn't matter where it occurs. We want 1 out of the 4 that skip. So let's say we get it first. That's 4 out of what? 120. Then what's left? Well, one of the DVDs is out of the shipment, but this is for a skip. All the rest, so if we went skip, good, 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 skip, good, 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 skip, good, 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 skip. So our sample space is 4 ways this could happen. We're only going to figure it out one way. It should look familiar to you now. And then for the good ones, if 4 skip, that means how many are good? Those of you that said 116, you are correct. But now, almost got carried away here. 1 DVD is out of the circulation. We chose it. We're not replacing. For another good one, now we're down to 115 out of 118. And then our third good one, 1, 2, 3, 4 DVDs chosen. We got 114 left out of 117 possible DVDs. All right, so as we multiply all this together, 6,083,040 on top, 197,149,680 as your denominator, giving you the probability with rounding right there. But what do we got to do? That's if it's first. It could happen here, it could happen here, and happen here. There are 4 possibilities. So times 4, giving you about a 12%, approximately 12% probability of that happening, somewhere in there. Okay. Now, can I do this with everything else? Well, think about it. We can. So look what I'm talking about. What we want over total. So for the skips, we want 1 out of the 4. Does it matter the order? It does not. Order, who cares? So we can do this. Again, you might like this. Fine, roll with it. But there's 4 of them. We don't care which one we get. So 4 combination 1. What do we do with that? We multiplied it by all the good ones we were choosing, right? Times. Well, how many good ones do we have to choose from? Well, 4 are bad, 116. Combination, don't care the order they're in, but how many of those are we going to take? Well, if one of them is bad, we need 3 there. So these are the skips. Those are the good ones. Over, again, we're not caring about an order in this particular problem. We had 120 DVDs to choose from, and we were choosing 4. So as we look at this setup, what's this setup help produce? Well, instead of having to get our sample space and multiply by 4, you'll see this. Sorry. We get 1,013,840 divided by 8,214,570. And if you divide that out, it's going to be an answer of 1, 2, 3, 4. Now, why are we off? Rounding. But we're not off by much, so we'll be okay with that. So let me change gears on you here. One more question with it. What's the probability you select exactly 2? All right, so we want exactly 2. So let's talk through this here a little bit. Again, what we want over total. What we want over the total. So we could set it up this way. We need a skip, and a skip, and a good, and a good. So 4 out of 120, skip. But then we want the next one to be a skip, so that takes that down to 3 over 119. Then we need good ones. Well, again, how many good ones are left? Still 116. But we've taken a disc out, 118. Now we've got one less good one, so we're down to 115, but we've still taken another disc out over 117. Now, here's the problem. How many different ways can this happen? Well, skip, skip, good, good. Skip, good, skip, good. We could go good, skip, skip, good. We could go good, good, skip, skip. We could go good, skip, good, skip 1, 2, 3, 4, 5. And finally, we could go skip, good, good, skip. It's going to our sample space as we get more things is going to get quite not expensive, but quite expansive. So we get 1, 2, 3, 4, 5, 6 ways. Or start using our combination. We don't care the order. Out of 4 DVDs we're choosing, we need 2 of them, however you want to look at it, that skip. Well, if you do that in your calculator, you get an answer of 6, so it's telling us our sample space. So instead of doing all that, because we have to multiply it by 6, we can use this to help us out now. So here's our setup. We'll go 4 combination 2 that skip, times, that's that part right there. What's left? There's 116 good ones, and we need 2 of them. So that's that. Out of, we're still taking, out of the 120, we're choosing 4 of them. Rounding my answer to there, there's what we have. Again, it takes me a little while to write these down and go through them, so that's why I'm giving you a day or two to get these done. I got one more example, but I'll post that later today.